Team Fliegelschnurz, I have your question for the day. What is a cat's favorite nursery rhyme? And I've already asked you this. 3 blind mice. Then he can just have a feast. Have you ever stopped to think about how gruesome a lot of these fairy tales, not the fairy tales, what's that called? A nursery rhyme? How many of these nursery rhymes are gruesome? The original Grimm's fairy tales really were grim. Of course, the Grimm had 2 M's in it, and it was the author's last name, but you know, 3 blind mice, see how they run. They all ran after the farmer's wife, who cut off their tails with a carving knife. I mean, that's just sort of really disgusting, as if cutting off a mouse's tail would do anything. Anyway, so, Miss Bree, make sure that you do not tell your mother about this story lest she go, Okay, anyway, we are going to do example number 2 now from section 2.5. This is a distance equals rate times time problem. So this is a speed problem. You should have memorized that distance is always equal to rate times time. Now, you know that if you are going to be traveling 600 miles to Grandma's house, and you travel 60 miles an hour, and you're now traveling with your father who never stops, not to go to the bathroom, not to eat, not to do anything, and you're going average 60 miles an hour, you get on the road in West Texas and you drive 600 miles in West Texas. I don't know where that is, but you don't stop. How long is it going to take you to get to Grandma's house? Well, it's going to take you exactly 10 hours to get to Grandma's house, because time is how far you have to go divided by the speed at which you are covering that time. So in other words, time is equal to distance divided by rate. Now what did I do with the erase? Time is equal to distance divided by rate. Rate is equal to distance divided by time. Distance is equal to rate times time. And it's this basic formula. This is the distance formula. Distance is equal to rate times time that we're going to use to solve these problems. So let's see what information we have. Ted and Jeff plan to meet at a campground at noon. Ted leaves at 9 a.m. and Jeff leaves at 9:30 a.m. If Jeff drives an average of 8 miles an hour faster than Ted, find the speed of each of them if they both arrive on time. Now there's a lot of things that are going on in this problem, so let's go ahead and take it a phrase at a time. We'll dissect it and see what information we have. Okay, they want to meet at noon. Meet at noon. But before I do that, let's just go ahead and do a distance here. We're going to have our time. Our distance is equal to rate times time. And we're going to have Jeff and we're going to have Ted. So I have Ted here and we have Jeff. Now, let's see what information we can have and what we're going to want to solve for. First, we're going to have to figure out what we want the variable to be. And the variable is going to be, we're going to use x for a variable, in order to be where we can find whatever that particular item, maybe Jeff's time in relationship to Ted's time, maybe the distance that Ted travels in relationship to the distance that Jeff travels, or maybe the rate that Ted travels in relationship to the rate at which Jeff is traveling. Because with these variables, you have to be able to find the solution for one part of the problem in terms of the other part of the problem. So they're going to meet at noon. So what's that mean? That means they both get there on time. Okay, now let's see what we have. Ted leaves at 9, Jeff leaves at 9:30. Jeff drives 8 miles an hour faster than Ted. Right there, their speed or their rate is being given one in terms of another. See this? Jeff drives an average of 8 miles an hour faster than Ted. So why don't we say let x equal Ted's speed. Let x equal Ted's speed. If x is equal to Ted's speed, what is going to be equal to Jeff's speed? Well, what does it say? It says Jeff drives an average of 8 miles an hour faster. So if this were 50 that Ted were driving, being a guy, it probably wasn't 50, unless it was through the woods on his four-wheeler. But Jeff drives 8 miles an hour faster, so Jeff would be driving 58. You get the 58 by adding 8 onto Jeff's speed. So our variable describing Jeff's speed would simply be x plus 8. Now, let's see what we know. We can fill in that Ted's speed is x, Jeff's speed is x plus 8. Now, what can we do about the time? Do we know anything about the time? Well, we know they were supposed to leave. We know they were supposed to meet at the campground at noon, and that little piece of information there is really important, but it might have been pretty easy to go right past your eyes because you're not seeing numbers. What is noon? Yeah, noon is 12 o'clock. So, one of them's getting, they both get there at noon. One of them leaves at 9 o'clock, one leaves at 9:30. Jeff leaves at 9:30 because he's driving faster, and Ted leaves at 9 o'clock. So if they leave at 9, Ted leaves at 9, gets there at noon, how long has he been traveling? 9 to noon, 3 hours. So our time is 3 hours. Jeff's time, he leaves half an hour later. He travels half an hour less, 2.5 hours. Now, what do we know about distance? You can calculate distance. Distance is equal to rate times time. What is rate times time? 3x. 2.5 times x plus 8. Okay, so now we have our box filled in. 3x, 2.5 times x plus 8. I didn't leave enough room, I'm sorry. Now, rate and time. Now what can we do using the information that we've organized in our box here? What can we do? What relationship is there that will help us to come up with an equation? What two things are equal? Well, their speed's not equal, their time is not equal, but the distance that they travel, believe it, we're to assume, let's see, we're assuming that the distance that they travel is the same. So what's the distance that they travel? Ted travels 3x. Jeff travels 2.5 times x plus 8. This is our equation that we're going to solve. We have 2.5 as a decimal here. You can either do the decimal multiplication out if you want to, or you can multiply both sides of the equation by 10. I'm going to show it to you multiplying both sides of the equation by 10. We have 10 times 3x is equal to 10 times 2.5 times 8 times x plus 8. When you multiply 10 times 3, simple, 30x. This eliminates the decimal point, is equal to 25 times x plus 8. It just makes our arithmetic a little bit easier. 30x is equal to 25x plus 400. That's an easy one to do anytime you think 25. If you think quarters, you've almost instantly have the answer in your mind, don't you? You can tell me immediately that 8 quarters is not $4, is it? 8 quarters is $2. So it would be 200. We're going to isolate the variable on the left-hand side of the equation. So we subtract a 25x from both sides, and we have 5x is equal to 200. We're going to divide both sides of the equation now by 5. And we have that the speed at which Ted traveled was 40 miles an hour, miles per hour. The speed at which Jeff traveled was 48 miles an hour. So you're going to label them. 40 mph, Ted's speed. 48 mph, Jeff's speed. So they are definitely riding on mountain roads or something to have their speeds down low like this. This is an excellent example of a distance problem. You'll have a lot of these in algebra.